LightTools video, we will be discussing the need for declaring adjacent surfaces to be an optical contact, and then two methods for declaring adjacent surfaces to be in contact: an automatic approach and then a manual approach. LightTools assumes that all geometry is surrounded by the system's ambient material, regardless of its proximity to other objects in the model. For instance, in this model, we are trying to model an X prism where four prisms of identical index are touching. The ambient material is air, as it is in most systems. There is an NS ray tracing through one of the prisms which we expect to pass through the X prism. However, as you can see, the ray reflects at one of the internal interfaces between the two prisms. If we look at the NS ray properties at that segment, we can see that on one side of the surface is material and the opposite side is air. This indicates that the ray is TIRing. The simplest way to identify adjacent surfaces that should be an optical contact is to use auto-declare contacts. I'll start by selecting the four objects, then navigate to Modifying, Element Editing, Auto-Declare Contacts. You can see that this NS ray is now tracing through the prism as expected. We can double-check the NS ray properties and see that the material before and after the ray segment is now the identical material. Objects with surfaces in optical contacts are grouped together. In the Properties window, you can review the surfaces in optical contact on the Optical Contacts tab. In this model, there are four contacts created, one for each pair of adjacent surfaces. This window also lets you break existing contacts between surfaces. To demonstrate the importance of the optical contact setting during simulation, we'll start with a model from the LightTools example model library. In this model, there are two imported objects. The base has 7 protrusions, each representing an LED, and the dome has a cutout that fits over the base. Our goal is to make sure the appropriate surfaces are contacted together. Right now, LightTools will assume there is a small gap of air between these two entities. An NS ray with a width of nearly 180 degrees has been placed on top of the center protrusion. The traced fan does not look nearly hemispherical, as it starts in air and then refracts into the dome material. I've already run a simulation for this model, and the intensity loom viewer is shown on the right side of the screen. Note that the intensity falls off steadily from the peak. For this next step, watch the NS ray fan. I'll select the base and the dome, and select Modifying, Element Editing, Auto-Declare Contacts. The first thing you might have noticed is that the ray fan changed. Now that the air gap has been removed, let's run another simulation and see how our intensity distribution changes. As you can see, the change between the two simulations is significant. The intensity distribution is much wider now. While auto-declare contacts is a very convenient way to select optical contacts in a model, it is also possible to set optical contacts manually, surface by surface. In this third example, we have a hemisphere next to a plate. Auto-declare contacts would work in this scenario, but if we had a model where we wanted to set these relationships manually, the first step is to select the two surfaces you want to declare to be an optical contact. Now, go to Modifying, Element Editing, Declare Contact. As you can now see, the NS array that was TIRing off the interfacing surface is now transmitting into the block. The newly created group shows the contacted surfaces in the Properties Optical Contacts window. In this video, we explain the importance of optical contacts to achieve realistic ray tracing and simulation results. We then showed a way for LightTools to automatically set the optical contact relationships using auto-declare contacts, and then how to set the optical contacts manually. Note, one related topic that we did not discuss in this video is when objects are overlapping. In this case, you should set the immersion relationships in the Immersion Manager, as auto-declare contacts is not intended to help with these scenarios. Thank you for your attention. And if you have further questions, feel free to contact us at lighttools_support@synopsys.com.